Algebra 1 will be on Lesson 56, which is identifying, writing, and graphing direct variation. So first I'm going to do the exploration, that first example for using direct variation. It says, to make 1 pitcher of lemonade, 5 lemons are used. So if you want to get, this is just a little graph, if you want to get 1 pitcher of lemonade, then you need to use 5 lemons. And the ratio of lemons to pitchers equals 5. The pitchers is x, the lemons are y. Okay, so we have y over x, 5 over 1. Now, what if we wanted to get 2 pitchers of lemonade? We would have to use 10 lemons, and the ratio would be 10 over 2, which reduces to 5. And so on. If you want to do 3 pitchers of lemonade, you'd need 15 lemons. And you can keep filling out this graph. 15 over 3 equals 5. So our ratio of lemons to pitchers is always going to be 5. That is direct variation. Right here, we're using a ratio to solve for direct variation. You always use y over x. So in this case, lemons over pitchers. Okay, so the next part of the question says, write a function for determining the number of lemons needed. Okay, so this is always, direct variation is always going to be y equals k times x. Y and x are constants, so in this case, x is the pitchers of lemonade and y is the lemons. K is always going to change, so it's a variable. Okay, so we're going to put in what is the direct variation, what number are we going to use for k? That is going to be our ratio right here. It's going to be 5. Y equals 5x. This right here is going to be our function. And then in C it says, how does the coefficient of x, this is our coefficient, k, or in this case it's 5, how does the coefficient of x in the function compare to the ratio of lemons to pitchers? So this is our coefficient for this function, it's 5, and the ratio of lemons to pitchers is also 5, so it's the same. It doesn't vary, it's the same. Next, they ask you to graph the function. So here, you're just going to take your pitchers and your lemons. You're going to have some ordered pairs. X is going to be your first ordered pair and y. So our first one would be 1, 5. X, y. That's how we write our ordered pairs. Our next one would be 2, 10. And then our next one would be 3, 15. I don't even think I have enough space here to do, 3, 15, but we'll graph this. So this is our x-axis and our y-axis. So move 1 space to the right on the x-axis and up 5 spaces on the y-axis. And we're assuming it goes through 0. I don't even have enough space on here to graph it, but it's going to look like this. And if you wanted to do 2, you go way up here to 10. It's going to be a very steep graph. All right, now it asks you for question E. It says, how many lemons are needed for 8 pitchers? Okay, so let's write our function down. Y equals k times x, and the k in this case is 5, so y equals 5x. And the question said, how many lemons are needed for 8 pitchers? So our pitchers, which in this case is x, equals 8. And they're asking you, how many lemons do you need if you were to make 8 pitchers of lemonade? You just plug x, you plug 8 in for x, and you solve for y. 5 times 8, which is 40. You'd need 40 lemons to make 8 pitchers of lemonade. And then for F, it says, how many pitchers can be made from 47 lemonades? So let's write our function, y equals 5x. Now they're asking how many pitchers. They're asking us to solve for x right here. Okay, and it tells us that there are 47 lemons. So in this case, y equals 47. We'll plug that in and solve for x. So 47 equals 5 times x. To solve for x, you divide both sides by 5. So we have 47 over 5 equals x, because these cancel. Well, this is not going to be an even number, so we're going to have a little bit over whatever 47 divided by 5 is. So 5 goes into 47 9 times. So we're going to have 9 pitchers. That's what x equals. X, it'll have a little bit of a remainder, but we're not really too worried about the remainder. We can't have 10 pitchers. Okay, so this right here is direct variation. Y equals k times x. And we learned that when we wrote our first function down. The k is going to change. It's going to be some constant that changes. It can also be negative. It doesn't have to be positive. Your graph, we graphed this line, it's always going to go through 0, 0 for direct variation. And the way you'd say this equation, if you want to use words, y varies directly with x, or y is directly proportional to x. So you really, really want to keep in mind about y equals kx. All right, so now for example 1, it asks us to tell whether each equation represents a direct variation. If the equation is a direct variation, find the constant of variation. So this is our first equation, y plus 8x equals 0. All you have to do is solve for y, because we want it to be in the form y equals kx. This is our direct variation. We want to change all of the equations they give us to this form. So we basically just need to solve for y. So to do that, we subtract 8x from both sides. Y equals 0 minus 8x is going to be negative 8x. Okay, so we've solved for y, and they're asking us if the equation is direct variation. It is. It's in the form y equals kx. K is our constant. So our constant here is negative 8. So yes, it's direct variation, and it wants us to know what the constant of variation is. The constant's always going to be the number or coefficient in front of x. So k equals negative 8. All right. Now this one right here, y over 10 equals x. To solve this, we want to solve for y. We want to get it into direct variation form. All you have to do, right here, it's dividing by 10. You just need to do the opposite to get y by itself. So we're going to multiply both sides by 10. These 10s cancel, and we have y on the left, and then x times 10 is going to be 10x. Don't put x10, put 10x. You want your constant in front. Okay, now is this in direct variation form? Yes, y equals 10 times x. What is our constant? It's 10. Okay, our last one, x, y equals 6. We need to solve for y. We want it to be in this form, y equals kx. So to solve for y, you divide both sides by x. On the left, it cancels. We have y equals 6 over x. Another way to write this, if we want this to be by itself, you can write another way, but really we're not too worried about it because it needs to be in this form, y equals k times x. This is not the same form, it's not direct variation. So no, it's not direct variation because we need to have 8 or a constant times x. This is a constant divided by x, so it's not direct variation. Another way that you can solve, and we did it in our exploration, another way you can solve and decide if you have direct variation, when you're given ordered pairs, if you write them as a ratio or a fraction, then if the answer for each of those is the same, you have direct variation. So right here, we were given 3 ordered pairs, and they want to know whether or not we have direct variation between these 3 ordered pairs. So what you need to do is you need to find a ratio y over x. Always y over x for direct variation. This is x, this is y. X, y, x, y. We need to solve each of these. If we get the same answer for y over x, then we have direct variation. So for this first one, y is negative 14, x is 2. Negative 14 divided by 2 is negative 7. Right here, y is negative 35, x is 5. Negative 35 divided by 5 is negative 7. So far, we have the same answer. And then right here, x is 21. Y is negative 3. 21 divided by negative 3 is negative 7. We have the same answer for each set of ordered pairs. So yes, we have direct variation. Then the next one, we have 2, 4, 3, 5, 5, 7. Y over x, 4 over 2, you get 2. 5 over 3, it doesn't reduce anymore. If you want to write it as an improper fraction, you can, but just leave it as 5 over 3. It's not the same as 2. It's going to be like 2 and 1/3. And then right here, y over x, 7 over 5. Again, that doesn't reduce down. It's not the same. These are not the same. Even here you can tell because the denominators are different. Okay, so no, we do not have direct variation for these ordered pairs. Next, example 3. It says that we need to write an equation for direct variation that includes the point 6, 24. Now, our formula for direct variation, y equals k times x. Y and x, we can plug that in. K is a constant we'll have to solve for. So the very first thing you need to do is you need to plug this point into your equation. Y is 24 right here, x is 6. So 24 equals k times 6. And what you need to do is solve for k. That's the very first step. So to solve for k, you divide by 6. 24 divided by 6 equals 4. So we have our constant, your constant of variation. It's always going to be some number right here. Now what we need to do to write our equation is just plug this 4 back into our direct variation form. Y equals kx. So if we plug 4 in for k, y equals 4x. This is our direct variation, that the equation for direct variation that goes through this point 624. Next, excuse me, it says the distance a person runs varies directly with the time spent running. If a person runs 12 miles in 2 hours, how many miles will the person run in 3 hours? And you could probably figure this out in your head, but just to get the practice for direct variation, we are going to write our equation. There's 2 ways to do it. The first one, the equation y equals k times x. And this is where we need to focus. It says that the distance a person runs varies directly with the time. So distance varies with the time. So our first point, we have 12 miles in 2 hours. X is going to be 2. Y is going to be 12. Because if we were to write it as a ratio, we have y over x. Our distance varies directly with our time. Okay, so this is our point 2, 12. 2 hours, he ran 12 miles. So we're going to plug that in here. Y is 12 equals k times 2. We need to solve for k, so divide both sides by 2. So k equals 6. If we write that as an equation, we have y equals 6x. So that is our equation. And now the last part of the question, it says, how many miles will the person run in 3 hours? Now, hours is x. So now in this case, we have x equals 3. We want to figure out how many miles they're going to run if they run 3 hours. So y equals 6 times 3, which is 18. They'll run 18 miles. Okay, so this is the first way to solve it. This is the second way to solve it, to write it as a ratio. So y over x. We know what y is. It's 12. X is 2. Okay, so we have 12 over 2. If you want to solve and figure out how many miles the person's going to run in 3 hours, you use a proportion. So our first ratio is 12 over 2, and a proportion always has an equal sign. We need to find out how many miles they'll run in 3 hours. So it's y over x. We know that x is going to be 3 hours. So to solve for y, you just cross multiply. 12 times 3 is 36, and 2 times y is 2y. Divide both sides by 2, y equals 18. So you can use either method to solve, whichever one makes more sense to you, writing this equation out or using a proportion. And the last example says the grocery store sells 3 pounds of lemons for $1. Graph the relationship and then use the graph to estimate the cost of 12 pounds of lemons. Okay, so in this case, they have 3 pounds of lemons for $1. Okay, so the pounds of lemons, we have y over x is our ratio. The pounds is going to be x, pounds of lemons, and y is going to be $1. Okay, so we have 3 pounds for $1. So 1 goes on top, 3 goes on bottom. This is going to be, in essence, it's going to be your slope. Okay, so if you want to write it as an ordered pair, x goes first, so it's 3, and then y goes second. Okay, remember you can always write it as an ordered pair. Now if you go down here to graph it, 3 is the pounds of lemon, or x, so I have it on the x-axis. Y is the dollar amount that it cost. It cost $1, which I have on the y-axis. So if you want to graph your first point, 3 pounds of lemons cost $1. That's our first point. And remember, direct variation always goes through 0, 0. Now we need to figure out our second point. It said graph the relationship and then use the graph to estimate the cost of 12 pounds of lemons. Okay, we have 12 pounds of lemons. We're going to use, you can use either a ratio or an equation to solve for y. Y equals kx. I'm going to use the equation. So we know for our first equation, we need to solve for k. Our first equation, x equals 3 and y equals 1. Okay, so 1 equals k times 3. To solve for k, you divide both sides by 3. K equals 1 over 3, because these cancel. Do you see how it's the same right here as our proportion? 1 over 3, 1/3. That's basically going to be, 1/3 is going to be your slope on the graph. So you could always, if you wanted to go up 1 and over 3, up 1 and over 3. But right now, if they ask you to find something really, really a big, large pound of lemons, then it's going to take a while. So they told us, what if we have 12 pounds of lemons? So what if, this is our equation, y equals 1/3 x. What if x equals 12? So plug that in, y equals 1/3 times 12. Another way to write this is 12 over 1, so you don't get confused. Now we need to solve for y. Just cross cancel. 3 goes into itself 1 time and it goes into 12 4 times, so y equals 4. So we know what x is, we know what y is, we have an ordered pair. 12, 4. So if we want to find out how much it's going to cost to get 12 pounds of lemons, go over 12 spaces on the x-axis and up 4 on the y-axis. And that's going to give us our point, and you can draw your graph. And there you go. All right, so I'm going to have you do questions, the practice questions, A through I. And if you have any questions, let me know.